Welcome back. This is an Aleks training video on knowing the properties of the common types of nuclear radiation. There are three types of radiation. You have, and they're named after the first three letters of the Greek alphabet. You've got alpha radiation, and an alpha radiation is really the nucleus of a helium atom. So these things are actually falling apart, and so whatever atom that you have that's undergoing alpha radiation is actually falling apart and getting smaller and smaller and smaller. It's throwing mass away, so it becomes less and less and less. Okay, so uranium go to thorium, etc., and just keep falling. So it's if you want to think of helium, the helium is going to be 2, 4. So that means it's got 2 protons, but remember this is this is the nucleus, so this would be +2, so its charge would be +2, and its weight or its mass would be 4. Okay, and that is not just energy, that's matter, that's actually stuff. Okay, so that would be stuff. So alpha would be matter. The next one is beta. And beta is essentially really high speed or high energy electrons. So this is beta. And an electron, remember its charge is going to be -1 and its mass is 0. Right? So in a beta, the mass would be 0 and the charge is -1. The last one is called gamma. And gamma is 0 mass and 0 charge, and so it just looks like this, and there's no mass there, it's just energy. Okay, so if you want to think of the beta as having some mass, it's not completely massless, but when you round it to its nearest AMU, it's still going to be 0. All right, so it would be a mass of 0 and a charge of -1 for beta. Gamma is 0 and 0. Well, they're going to give you some mass and some charge, ask you what the particle is, whether it's energy or matter, and what it can be stopped by. I should have said that before. Alpha is really slow and luggy, and skin can stop it, or paper can stop it. So definitely a lab coat could stop it. So alpha particles don't travel very, very hard or fast. Beta is a little more fast moving since it's electrons. So it could penetrate your skin, but just normal walls or your lab table could stop it. Just normal walls, so it wouldn't, like if the next lab had something that was sending out electron beams, it wouldn't penetrate the walls. It'd be fine. Now gamma is very high speed, very powerful, low wavelength, high energy, and it would take a few inches of lead or really heavy concrete walls. Usually if you're spitting out gamma in a college, they usually have that in the basement of the science building where nobody ever goes, so that they can keep people from dying, because gamma radiation is what you would have if you had radiation treatment in a hospital, and so that's a little bit different. All right, so let's look at it. First one they have is a mass of 0 and a charge of 0. Okay, well that one is gamma, obviously, because that's 0 and 0. So this is going to be gamma, and you would just pull that down. It's a pull down menu, drop down menu. Okay, and gamma has no matter, it's just energy, so you would just pick the energy, and it can be stopped by lead or thick concrete, whatever the drop down says, something like that. The next one has a mass of 4, so that's definitely, if it has a mass of 4, it's matter, because it's got something. Those are AMUs, that's matter. It's got a charge of 2. Okay, well that's alpha, so that's an alpha radiation, and alpha radiation can be stopped by a sheet of paper or skin, whatever the drop down says. It's something like that. Okay, I hope that helps.